Welcome all, welcome back at C squared. In this lesson we'll talk about tangents, and you have here the definition of a tangent. A tangent to a circle is a line or a segment in the plane of a circle that touches the circle. Touches means only one point, like in this case you see this point A. Okay, this point is called point of tangency, and we have here a theorem that goes along with this tangent, which says in a plane, so be careful, it's working on in a plane, a line is a tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. You can see here the picture of this theorem. You notice RA is perpendicular on tangent AB. Now be careful, this if and only if tells you it works both ways. The converse will be also true, and you will see it. We'll use it in this lesson. So now, first example of a problem that you need to know about a tangent. In fact, if you take a look here, it says consider the figure below, find the length of AB. I'm going to call it X. And if you take a look, AB is a tangent to the circle R. How do we know that? We notice this right angle here. If RA is 6 and BC is 4. So my first thing will be here to draw this right triangle I mentioned. We need to find this X. We know this is 6. Now we need to find out how long this side of the right triangle, the hypotenuse, is, which is this segment. And that segment will be this 6, because this is a radius, which is the same with this one. Both of them are radii. So this is 6 plus 4. This is 10. So now we can use Pythagorean theorem. A squared plus B squared equals C squared. Be careful how you identify A, B, and C. Be sure the longest side, the one on the opposite side of the 90-degree angle of the right angle, is the C. The other one are A and B. So I'm going to say X squared plus 6 squared equals 10 squared. And we have here X squared plus 36 equals 100. We know you need to find X. So first thing I'm going to do is subtract 36 on both sides. And we get X squared equals 64. And the last step for finding X is to take square root. Since this is geometry, you don't need to put plus and minus. We just keep it the positive value, and square root of 64 is 8. Don't forget, this X is nothing else than the length of the segment AB. Let's see another example. You notice very similar. The picture is the same. However, let's take a look. Now they said find the radius of circle R. Oh, find this X or this X, right? I call them both X. Both are radii. If AB is 17, this is 17, and BC is 4. So you will see I'm going to draw the same triangle, the same right triangle. Now this is 17, this is X, and this segment here, the hypotenuse, because it's on the other side of 90 degrees, is going to be what? X plus 4. It's an expression here. So now I'm going to use again the Pythagorean theorem. A squared plus B squared equals C squared. So what do I get here? We get X squared plus 17 squared equals X plus 4 squared. So now we're going to have here X squared plus, let's see how much 17 squared is. $17 squared is 289. And for the right side, you can FOIL it, or you can use this shortcut, A plus B squared. If you know this shortcut, that will be good. A squared plus 2AB, so don't forget that 2 plus B squared. So we have here X squared plus 2 times x times 4, that will be 8x, plus b squared, which is 4 squared, which is 16. Now, if you are scared because it's a quadratic, don't be scared, because look at here, we can cancel out this x squared. One is on the left side, the other one is on the right side. So in fact, we have a linear equation, 289 equals 8x plus 16. I'm going to subtract 16 on both sides. 289 minus 16 is 273 equals 8x. And the last step for finding x, divide by 8 to get rid of this 8. So we have x equals 273 divided by 8 is 34.125. However, read the problem. They ask you to round it to the nearest hundred. So I'm going to round it. I'm going to say 34.13. And that x is nothing else than the radius. The radius, I'll call it r, or if you want to call it RA or RC, that will be fine. Either way, it's 34.13. And a very similar problem, however different. You'll see. Find the length of BC. I'm going to call this one x now. If RA is 14, this is 14, and AB is 48. Now I'm going to put another 14 here. By now we know these two segments RA and RC are the same, because they are the radii of circle R. So again, I'm going to draw the same triangle. We don't really need it, but let's do it. This is 48, this is 14, and this segment here is going to be an expression like the previous problem, x plus 14. Now, the same Pythagorean theorem, a squared plus b squared equals c squared. So you're going to have 14 squared plus 48 squared equal x plus 14 squared. So now let's grab the calculator. 14 squared, I think that is 196, but let's be sure. That's 196 plus 48 squared. That will be 2304. Now for the other side, I will say this: leave it like that. Don't do anything. You can, but it's going to be more complicated. I'm going to leave it like that. Now I'm going to add the two numbers on the left side, and I get 2500. And now you'll see why I said leave it like that, because now if I want to find x, I'm going to take square root here. Okay, I'm going to take square root of the left side, obviously the square root of the right side. Square root of 2500 is 50. I'm going to just keep the positive value equal. And this expression, if you take square root, is going to be x plus 14. So you notice it's a lot easier to do it this way instead of foiling. And the last step to find x, subtract 14. X equals 36. Don't forget the x is nothing else than the length of segment BC. And now the next problem you see here, in fact, we're going to use the converse of the theorem we talked about in the first three examples. Why? Because here it says determine whether NT is tangent to circle M. So now we want to find out if this is a right angle. We do not know. If NM is 9, if NT is 40, and MT is 41. Let me erase this right angle here. We do not know that. We want to find out. So now this is going to go also with Pythagorean theorem, right? If you remember, a squared plus b squared equals c squared. But we're going to use the converse. What do I mean by that? List the number, and you notice I start with the smallest, 9, 40, and 41. And verify if these three numbers accomplish this Pythagorean theorem. What do I mean by that? Like this, 9 squared plus 40 squared. Is this left side equal? That's the reason I put a question mark with the right side, which is 41 squared. So this is the converse of the Pythagorean theorem. Again, 9 squared is 81, 40 squared is 1600. And let's do 41 squared on the calculator. That'll be 1681. And now we notice on the left side we get also 1681. So yeah, we have a right triangle. Why? Because it's accomplishing this Pythagorean theorem. So now I can, based on this one, I can say what? Triangle MNT is a right triangle. Because this is a right triangle, then we have a right angle. But which one is going to be the right angle? Obviously the one on the opposite side of the longest side. So this will be now a 90-degree angle. So I'm going to write that here. The measure of angle N is 90 degree. Which means what? Which means NT, segment NT, if you want to call it like that, is perpendicular on segment MN. Which means exactly what we need to determine. Determine whether the NT is tangent to circle N. Yeah, it is. Okay, so this last part is more like a proof based on the algebra, the geometry and the algebra. We did it on the first part, and then we have logic statement. The next part of the lesson we're going to still talk about the tangent, but now you see we have two tangents starting from the same exterior point, in this case A. In this case we have a property which is right here. These two segments, these two tangents are congruent. Why? Because they start from the same point, exterior point. Okay, but we also have another property, you see it here. So beside these two segments are congruent, also we have this property that is useful if you remember. This angle and these angles are supplementary. That's the meaning of 180. Okay. And the angle A is called circumscribed angle. In case you hear this word, that is the meaning. Angle A is circumscribed. So two property here. So now let's see how we use this property in this example. When you notice we need to find the value of x and y. We notice x is in these two expressions, AB and AC. And what do we know about AB and AC? We know these two segments are congruent. Why? Because they represent the tangents, the only two tangents in fact, from point A to circle M. They have to be congruent. So the geometry is AB congruent with AC because they are tangent to the, which also means AB, the measure of AB, of segment AB, and the measure of segment AC are the same, which give us this equation, 6x plus 8 equals 2x plus 24. And we want to find x. I'm going to subtract 2x to get rid of these 2x. We have 6x minus 2x is 4x. Plus 8 equals 24, minus 8, to get rid of this, plus 8. Obviously on both sides we have 4x equals 16, divide by 4 to get rid of this 4 that is next to the x, and we finish the x equals 4. And let's take a look now to y. How do we find y? We want to look to these two angles, A and M. A and M, remember these two angles are supplementary. Okay, so we have the measure of angle A plus the measure of angle M equals 180. So we're gonna have here 6y plus 5 plus 10y minus 1 equals 180. So now we're going to combine the two y's, 6y and 10y, that will be 16y. The numbers, the positive 5 minus 1, that will be plus 4. Now let me move here to have more space. My next thing will be to subtract 4. To get rid of these 4, don't forget to do on both sides. And we have 16y equals 176. The last step, divide by 16 to get rid of this 16. So we finish with y equals 11. So remember these two properties that comes with the two tangents you can draw from any exterior point to a given circle. And we're going to use the same property here, where we need to find the perimeter of each polygon. So let's start with A, and let's take a look. You notice this is 16, and these represent the segment AF. Segment AF and segment AD are congruent. Why? There are two tangents starting from the same exterior point. So I'm going to put 16 here. Now I'm going to move to point B, and you notice we have this tangent BD and this tangent BE. These two are congruent. So 12 here and obviously 12 here. And very similar for point C. Two tangents starting from point C. So these two segments are congruent. So if this is 9, this is 9. So what else we need to do to find the perimeter? We need to add all these numbers, but I can give you a shortcut here. If you notice, we have 16 twice, so we're going to have 2 times 16. We have 12 twice, so we're going to have 2 times 12. And we have 9 twice, 2 times 9. So that will be 32 plus 24 plus 18. 32 plus 18, that will be 50 plus 24, 74 is the perimeter of this triangle ABC. Now, you notice down on the slide I have two vocabularies: circumscribed polygon. So both polygons you see here, the triangle ABC and the quadrilateral ABCD on part B, are circumscribed polygons. They go around the circle. And also inscribed circle. Okay, so in this case the circle is inside, we call that an inscribed circle. Now let's move to part B. We're very similar. We can say, hey, this is 7, because this is 7, right? This is 3, because this is 3, then they are congruent. If this is 4, this is 4. And obviously the last one will be 5, because this is 5. So how do we find the perimeter? Very similar. I'm going to use that shortcut I said, twice each number. 2 times 7, 2 times 3, 2 times 4, and 2 times 5. So what do we get here? We get 14, 6, 8, and 10. We have to add these 4 numbers, and that will be 20, 30, 38. Okay, and that is about this example. The next example, very similar, however a little bit different. We notice we have two circumscribed polygons, or if you want to call two inscribed circle on A and B. Let's take a look. We need to find the value of x first, and you notice x is right here, which represent the length of segment AF, which is congruent to the length of segment AD. So the question is, can we find how long AD is? And the answer is yes. Why? Because we're looking here and we see BE is 10, which means BD will be also 10, because they are the two tangent that comes from point B to circle M. And now we know that this segment DA should be 24. If you do not see where this 24 comes, right, we have 34 here minus this 10. That will be 24, okay? Or 10 plus 24 is 34. So now the equation for finding x will be what? 5x plus 9, right? The segment AF is congruent with the segment AD. So 5x plus 9 equals 24. Subtract 9. So we have 5x equals 15, divide by 5, x equals 3. So we finish the first part. We need to find the perimeter, and I think we know what we need to do here. First of all, this one will be 24. We said 10 and 10, this is 18, and obviously this is going to be 18. So we have all the numbers we need to find the perimeter. I'm going to put it up here. That will be twice 2 times 10, 2 times 18, and 2 times 24. So we have 20, 36, 20 plus 36 plus 48. Let's see how much that is. 20 plus 36 plus 48. That will be 56 plus 48, 104 units. And that's part A. Part B, very similar. We're going to need to find x first, and we notice x goes with 2x plus 1. Okay, so we need to find the length of segment CF. If this is 5, this is 5, and that means this is 15. So we have 2x plus 1 equals 15. I'm going to subtract 1, and I have 2x equals 14, divide by 2, x equal 7. Now we'll move into the last part of this problem, which is finding the perimeter. So we know this is 15. This will be 15 also. That's the starting point for finding x. 4 here, so obviously this is going to be 4. 12 here, and obviously this is going to be 12 because they are congruent. So now we can do the perimeter, which is going to be what? Twice 15, 2 times 15, 2 times 4, 2 times 12, and the last one 2 times 5. So we have here 30, 2 times 15, plus 8, 2 times 4, plus 24, 2 times 12, plus 10, 2 times 5. So we have here 40, 48, plus 24, and up to 72. The perimeter of this quadrilateral is 72 of this circumscribed quadrilateral. Very important to remember, I think, the vocabulary is useful. And the last problem in this lesson is this one, where we need to find the value of x. and y and the perimeter of the triangle. Very similar with the other problem. However, let's take a look. How do we find x? If we take a look, we notice x is here and here. And what do we know about these two segments that are represented by these two expressions? And these two segments are congruent because they start from the same point B. So that's the reason I'm going to write here 2x plus 10 equal 5x plus 1. And again, the reason is very simple. BD and BE and BE are congruent. They start from the same exterior point and they are tangent to circle M. Oh, let's solve this equation. I'm going to subtract 2x. And I have 10 equals 3x plus 1. Subtract 1 on both sides. And we have 9 equals 3x. Divide by 3. We have x equals 3. Because we need to find the perimeter of this triangle, so let's plug it in, and we have 2 times 3, it's 6 plus 10, that is 16. So this will be 16, and you can verify this will be also 16. 5 times 3, 15, plus 1, 16. So we're going to need this for the perimeter. Now let's find y. If you notice, y is right here. So if you in your mind you have this equation, 5y minus 4 equals 3y plus 10, that is correct. Just be sure you know the reason. The reason is AD congruent with AF. Those two are the segments represent the tangents from point A. Again, I will do very similar math. I will subtract 3y. And we have 2y minus 4 equals 10. Add 4. And we have 2y equals 14. Divide by 2. Y equals 7. So we have x, we have y, we need to find the perimeter. Again, very similar. I'm going to plug in here 7. 3 times 7, 21, plus 10, 31. And this one will be also 31. You can plug it in also to double check your work. 5 times 7, 35, minus 4, 31. And this is 14, so obviously this is 14. So the perimeter will be 2 times 31 plus 2 times 16 plus 2 times 14. And that will be 62 plus 2 times 31 is 62, 32, 2 times 16, and 2 times 14, 28. So we have to add these three numbers, 62 plus 32 plus 28, and that will be 122. The perimeter of this triangle is 122 units. And that's it. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.